To understand what a powerful force the Sun can be, take a look at Venus. At almost exactly the same size and mass as Earth, it's truly our sister planet. The thinking is that long ago, fierce solar winds stripped off lighter water molecules from its upper atmosphere. What was left was a witch's brew of acidic gases and carbon dioxide that thickened at lower altitudes, rising to some 90 times the density of Earth's atmosphere. At a concentration of 95% in Venus' atmosphere, CO2 gas trapped increasing amounts of sunlight and drove surface temperatures close to 1,000 degrees Fahrenheit. How did our Earth avoid such a harsh fate? One of the main reasons is that our planet has what Venus lacks: a natural defense against solar attacks. Earth spins around on its axis once every 24 hours. This has an effect on molten iron welling up from deep in its core. It's kind of like the alternator in your car. These plumes of hot metal generate magnetic fields that extend beyond our atmosphere and enshroud the Earth in a protective field. Venus, on the other hand, spins so slowly that one of its days is 243 Earth days long. That's one reason it lacks a strong magnetic field. While Earth's magnetic field may be strong, it's not impenetrable. In fact, when the Sun shoots a CME in our direction, and that blast coincides with Earth's magnetic field, that chain of events is called a geomagnetic storm. Air travelers, whose routes fly near the poles, get a slightly increased dose of radiation, and the crews who fly them often need to keep track of their cumulative exposure. But space travelers are at much greater risk. Earth's atmosphere thins rapidly with increasing altitude. Outside its protective envelope, those living on space stations get twice as much radiation as the rest of us, even when the Sun is quiet. When it erupts, as it did in 2003, astronauts and cosmonauts can absorb a whole year's radiation dose in just a couple of hours. With our dependence on computers and electronic communications growing by the day, we have begun to launch a fleet of spacecraft to monitor the Sun. Some positioned in low Earth orbit, others out where our magnetic field meets the solar wind, and even beyond. Data from these satellites are revolutionizing our understanding of the Sun and helping scientists predict solar eruptions more accurately than ever before.